Hello students, welcome to the video lectures of speech and natural language processing. So the agenda for today's class is we'll cover the following topics, that is about language modeling and grammar based language modeling and statistical based language modeling. And let us try to discuss about each topic in detail now. Before we go into today's topic, so that is about language modeling. So basically, what is language modeling and why we need this language modeling is the core part what we'll understand today. So language modeling assigns probabilities to sequences of words. It predicts the next word or sequence of words. It predicts the next word or sequence of words in a sentence, crucial for tasks like speech recognition, text generation, and machine translation. And language models are essential in NLP for predicting the likelihood of sequences of words. There are two primary approaches to building language models. First one is grammar-based, and the next is statistical-based. So these approaches differ in how they represent the language and handle various tasks such as sentence generation, speech recognition, and translation. Which means, so the language modeling is, it is the task of predicting the next word in a sequence. And it is based on the words that came before it. Okay, and this is broadly now, you can see the classifications which are mentioned over here. One is grammar-based language model, and second one is statistical-based language model. The names itself will reveal you what it is all about. So when we say grammar-based language models, these models use rules from the formal grammar to understand and generate the language. Okay, so here is the definition for your grammar-based language model, which rely on predefined sets of grammatical rules to generate or pass language. These models use formal grammars to determine valid sentences in a language. The components which it have are grammar rules and parsing. So they rely on some predefined syntactic structures like nouns or verbs or some phrases. And it also have some rules like we generally say any sentence in English with an agreement of subject and verb, that is subject plus verb plus object, right? And for example, a grammar-based model might use a context-free grammar to pass sentences and ensure they will adhere to the linguistic rules which exist. So the main advantage of using this grammar-based language is it will generate correct sentences, or it can produce grammatically perfect sentences to say, and it can capture the structure effectively. Okay, so let us try to understand this grammar-based language model using an example. So context-free grammar, a grammar-based language model uses predefined rules to construct sentences. For instance, consider a simple CFG for English sentences. Now, if you see, the rules are given here. So you just have a look at here. First one, the rule it is saying S implies NP and VP. It means the rule of a sentence, that is a sentence should contain a noun phrase and a verb phrase. A sentence consists of a noun phrase followed by a verb phrase. And we are defining what does this noun phrase have. So noun phrase implies determinant followed by a noun. A noun phrase consists of a determiner followed by a noun. Then it is a verb phrase. So verb phrase is determined to be, verb phrase implies verb followed by a noun phrase. Here it is mentioned a verb phrase consists of a verb followed by a noun phrase. And determiners are, this you already know, the or a can be the determiner in this. So for the feasibility to form some sentences on your own, just I'm mentioning you the nouns and verbs, and you can take your own noun or your own verbs, whatever you like, and you can also form some sentences based upon these grammar rules, which are mentioned over here. So the first grammar rule, it is saying the sentence will have a noun phrase and verb phrase, and the noun phrase is having a determiner followed by a noun. Verb phrase is having a verb followed by a noun phrase. Determiners could be B or A. So now the noun is cat or dog or a treat. Verb can be chased or ate. Now imagine these are the nouns and verbs which you have with you, and these are the determiners which you can use. Based upon this database or this grammar, try to build a sentence. And this sentence should be in such a form that it should satisfy this. A sentence consists of a noun phrase followed by a verb phrase. So the nouns are cat or dog or treat. Verbs are chased or ate. Now we can see here the sentence generation. Using these rules, you can generate valid sentences like the dog chased the cat. A dog ate a treat. So if you observe these two sentences, it is satisfying this. See, sentence should have a noun phrase and verb phrase, right? Now let us see here. The dog chased the cat. Now here the dog is followed by a verb phrase. The dog is a noun here. Chased is a verb. And you can see the cat is again a noun. Then a dog ate a treat. Again, the sentence is having a noun phrase and verb phrase. So that is a dog ate a treat. Clear? So what are the limitations we have here are, while this model ensures grammatical correctness, it can struggle with ambiguity. So that is the cat that the dog chased ran away. I mean, if there is couple of verbs or nouns that you have considered and trying to build a sentence which satisfies the condition of noun phrase and verb phrase, there could be some ambiguity of this kind. Then uncommon phrases or new slang which are not covered by the rules. Exactly, because the grammar based model is completely based on the rules from formal grammar. So it is being trained with the formal grammar to understand and generate the language. So that is the reason why it can produce grammatically correct sentences, but rather the only thing is uncommon phrases or new slangs which will not be covered by these rules. So let us see the strengths and limitations of this grammar-based language model. The strengths are, it produces grammatically correct sentences, absolutely. Then it is useful for applications requiring strict syntactic adherence. Since it is purely based on the rules from the formal grammar, it can produce you the perfect sentences which are grammatically correct. The limitations are rigid and may not handle natural language variations well. Then struggles with ambiguous constructions and slang. So then let us go to statistical language modeling. Let us have the definition first. Statistical language model, SLMs, use statistical methods primarily based on the frequency of word sequences in a large corpus to predict the probability of the next word in a sentence. Unlike grammar-based models, statistical language models do not rely on explicit rules, rather learns patterns from data. Understood. In our earlier approach of grammar-based language model, there the models use rules from formal grammar to understand and generate the language. And it is having the ability to produce the grammatically correct sentences. Whereas the statistical-based language models predicts the likelihood of a word or the sequence of words based on the patterns that are observed in the database. Whenever I say a database, it is a large text or large text corpora. Understood? So that is what the main difference between grammar-based and statistical-based. Grammar-based, it follows the formal grammar rules and generate the sentences, whereas here it tries to learn the patterns from the database, whatever you give. The database is the vast corpora. If I say a language like English, which is having a vast corpora, it is being fed to the model, and the model will try to learn the patterns out of this, and it will predict the sequence of or the next word which is going to come. Then now we'll try to understand about statistical based model using an example. So when I say statistical based example, here there is a need to understand this unigram, bigram, and trigram things. So unigram is one, bigram is two, and trigram means three. So what are these exactly? So generally, n-grams are contiguous sequences of n items from a given sample of text or speech. So generally, we have the concept of these n-grams in our natural language processing for doing the tasks in language modeling, especially. For example, let us talk about earlier called unigram, bigram, and trigram. So unigram means it's a 1 gram we call, which have individual words in it. That is one word. And bigram is 2 grams we call. It is pair of consecutive words. Then trigrams is 3 grams we call. It's a triplet of consecutive words. So let us illustrate, let us try to understand this unigram, bigram, trigram with an example. If you consider a sentence like the big cat, okay? So here the or the cat, which are single words or individual words, are called as unigrams. And if I say the same sentence again, the big cat, consider the big or big cat or the cat, where you can see the pair of words being pronounced by me. So that is 2 grams we call. It is termed as a trigram. Whereas trigram means the complete sentence, the big cat, okay, can be the trigram. Likewise, if you consider this sentence also, now I individually is unigram, like individually can be a unigram, to can be an unigram, eat can be a unigram, if you consider them as an individual words. And if you want a bigram out of this sentence, I like can be a bigram, to eat can be a bigram. And if you consider a trigram out of this, I like to is a trigram, like to eat is also a trigram. That is how this works. Hope you got this, students. So now these n-grams are termed to be simple statistical language model, which is based on a fixed window of the previous n words to say. So unigram will consider the probability of each word independently, whereas the bigram looks at the pairs of words which by considering only the previous word. And trigram will consider the last two words to predict the next one. This is how the unigram, bigram, and trigram works. And we'll try to evaluate these n-grams in our forthcoming lectures, because our second unit is based upon the word level analysis and n-grams separately. We'll understand this in deeper when we arrive at that video. So now let us understand this with an example which is given here. In a bigram model, you look at a pair of consecutive words to predict the next word. Consider a small training corpus. So I like to eat, I like to sleep, you like to play. So these are the three sentences which are existing in my corpus. So always remember, the corpus is nothing but a repository kind of thing, which you are providing it to the model. In other words, this is a data set which you are giving to your model to get trained. So now the bigram probabilities you can see, eat or to is equal count to eat or count to. So the chances or the probabilities of these things to occur in the sentences is 1/3. This is because you can see to eat is existing in the corpus one time. Okay. Then count to, that is TO2, is existing in the corpus three times, that is with three sentences. I like to eat, I like to sleep, you like to play. So that is the reason why we mentioned three. So the probability of occurrences are mentioned like this. So that is your sleep or play or eat will have one occurrence, but two will have three occurrences. This is how statistical model works. So sentence prediction. So whenever the user tries to, enter some text in your Google searches or anywhere, it will give you some prediction. What could be the next word? Hope this is encountered by each individual when you are browsing in your internet also. So similarly, the sentence prediction here is when gives the phrase like, I like to, the model could predict eat or sleep or play with equal probability based on the training data. So if you consider the training data in the earlier slide, here you can see this. I like to eat, I like to sleep, you like to. So you can see like to in the three sentences. And when the user enters I like to, so the model could predict eat or sleep or play with an equal probability, since these are repeated once in every sentence. So these are not present in any other sentence. So limitations are n-gram models can be limited by the context. Only look at a fixed number of previous words. Absolutely. That is the reason why we are getting there the probability as 1/3 when we consider eat or play or sleep with reference to two, because two is mentioned three times in the corpus, whereas eat or sleep or play is mentioned as a single time in the corpus. And suffer from sparsity, not enough data to predict rare sequences. So then next we will move on to the hybrid approaches. So hybrid approach is a combination of your grammar-based model and statistical models. Okay, this we'll also discuss about this in our next unit. And but as of now, the modern NLP approaches often combine grammar-based models and statistical models. In general, we term this as probabilistic context-free grammar. Okay, then neural network models. Neural networks such as recurrent neural networks, RNNs, or transformers build upon the ideas of statistical models by learning complex patterns in the data. They often implicitly capture syntactic and grammatical structures without needing explicit rules. Then the challenges in language modeling. So the challenges in language modeling are ambiguity and data sparsity, which we have discussed in earlier also. So ambiguity is both types of models, that is your grammar-based and statistical based, both suffer from the inherent ambiguity of natural language. Since this one classification will learn from the grammar, formal grammar, the other classification is trying to learn from your uh, patterns. That is the reason. And data sparsity also. Statistical models require vast amounts of training data to cover all possible word combinations, since it is having a direct or impact of the data set, whatever you provide. It works only with the corpus, what you will feed into it. That is the challenge of language. These are the challenges in language modeling. So hope you understood this. Thank you.